Hello dear audiences, welcome back to episode 11 of Statistics and Probability for Engineers. I am Mohammad Momenzadeh, the presenter of this lecture. So today we will discuss about the several items that is a joint probability distribution and joint discrete random variable and the concepts that are related to the joint distribution function. This lecture and a couple of next lectures will be designed for the engineers, and especially we focus on topics that engineers need it in their career. So if you are not engineer or you are not interested in a double integral or related concepts about these things, please skip from these topics and this content. So let us start our discussion by talking about the three-dimensional space and how can we deal with that one. So as you can see here, the function, the f, is a rule or is a concept that we have one entry inside of that one, means that we have a x, for example, in a one-dimensional space, and the output y is equal to f of x. We can consider the function as a machine or as a processor that the x go inside of that function and the output will be y equal to fx. If instead of one variable, means that instead of one x that we have it over here, if we put the ordered pair 2 entry inside of the function, and after calculating and processing on x and y, the output will be z equal to f of x and y, then we have the function of two variables, and of course to determine that type of the function, instead of using two-dimensional space, we need three-dimensional space. For example, over here, if we have x node as a one entry and y node as the another one, then for this x node and y node together we have one output. Let me just put the x node and y node to sketch the graph of a function. In this case we should do as follow, means that we have x node and y node, and the height of that point at the given intersection, which is denoted by z node, and it's equal to the f of x node and y node, f of x node and y node. It's gonna be the graph of this function, and if I just gather all of these points together, then I have a surface over here instead of having the curve. Means that at the end of the day we have a surface, that the given surface determines the value of a function at all points of x node and y node, x1 and y1 and so on. So this type of the graph determine the function of two variables. So in a real life, most of the cases has more than one random variable. Previously we talked about the single random variable, and we said that the random variable is a function by itself. If you remember that, I can mention it over here. If we have a sample space, let us denote the sample space by the things that we had it before. So we just put them in one, the sets like this, that all possible outcomes listed over there. So over here, instead of having the single points like the previous cases that we had it, each points over here determined by two variables indeed. So means that, for example, we have x node and y node as a 1 point of our sample space, or our sample points are formed in this shape. So we have x1 and y1 and x2 and y2 and so on, means that we can put all this type of the variable, and right now the random variable for them is a function over here that denotes the values by some numerical values. So over here we have two random variables. So let us take a look at the example and see that how can we deal with this situation. So as you can see in the definition over here, the function over here of f that can be denoted by x and y. We can put the index of x and y to emphasize about the random variable, means that we can write the probability distribution function by two indexes over there, that is x and y, and we put the value of x and y, the lowercase of x and y, inside of the function to denote the probability distribution function, and we call it the joint probability distribution of a discrete random variable. I think that in this lecture we will discuss about only the discrete cases, and in the next lecture we will talk about the remaining parts. So the first thing is as the same as the previous part, means that the function should be positive for all given values. Over here, being positive means that the surface should be over the z equal to 0, over the ground indeed, and the double summation of the value for fxy should be equal to 1, means that the addition of all cases should be 1, and at the end of the day the probability of random variable x equal to x and y equal to y is as the same as the value of a function over there. And for any region in an xy plan, the probability of xy belonging to that region is a double summation over the given region. Indeed, over here we have three-dimensional space. Let me just sketch the situation here. So as you can see here, we have a three-dimensional space, and to sketch the three-dimensional space we need two perpendicular lines that is denoted by z and y over here, and the x is the another line that we put it here. So we have two random variables that we denoted over here. For each sample point we have two values. One of them is denoted by x and the another one by y. For instance, this x nude and y nude. So we may have the several values over here. For example, we can have x1 and y1 over here. Each point should be denoted by two component. It's not only one component over here. We have two components, for example x1 and y1, and we can have the x3 and y3. For example, we can have several values over here based on the things that is defined on a question. So we have x3 and y3 as I said it, and for each of them I have one value that determine the highest of a point at that given values. And for calculating the probability of one region, for example, if I want to calculate the probability of this region, I should calculate indeed the value of a function, the addition of the value of the function over there, means that I should take this double summation to calculate it. Let us take a look at one practical example to see that how it can be worked in one example. So let us take a look at this example. The plastic covers for CD is a name of this example. It's a discrete joint probability mass function or probability distribution function. Measurements for the length and width of a rectangular plastic cover for CDs are rounded to the nearest millimeter, so they are discrete. So let us consider it like this. I mean, if we have a compact disc, there is a cover for that compact disc which is rectangular. So I consider that rectangular cover with the blue color over here. And for each cover rectangular things that we have two lengths indeed. One of them is denoted the width of the rectangular that we denoted by W over here, and this one determine the random variable y, and the another side of that rectangle which determine the length of that one, means that this side is denoted by x. So we have two random variable over here, and based on a calculation the possible value of x are 129 and 130 and 130 for this actually length millimeter, 130 and 131. There are three values over here, 131, and we have two values for the y as well. There are 15 and 16, so we have 15 and 16 as the values for the y. So totally, if I put them in one table, as you can see over here, we can see the values as follow. I mean, the y value is 15 and 16, then the x value is 129, 130 and 131 millimeter. So over here we have indeed 6 places and 6 probabilities. For example, 0.12 determine the probability of getting the cover of a compact disc with the length of 129 and width of 15. The dimension of 130 times 15 is 0.42, the second value over here, and so on, means that all the values are given in this case. If I just calculate one row or column of this actually table, then I can find the another distribution. For instance, over here, if I put the summation here, then the summation of them can be considered, means that 0.12 plus 0.42 plus 0.06. So it will be 10, 0.6 will be the addition of these values. And if I just consider the value over here and add them together, then the summation of them 0.08, 0.28 and 0.04. It's gonna be, if I just add them together, it will be 0.4. Right now, without considering the x, we have the value for a y, means that I can separately find the another distribution function. What do I mean? Means that I can make another table here and put only the value of y. If I put the value of y over here only, then I can see that without considering the value of x, for y equal to y I or yj, doesn't matter that what type of the index are you using, then I have one function that I denoted by g of y, that is a distribution for only the value of y. So as you can see, for the value of 15 we have 0.6 as a probability, and for the value of 16 we have 0.4. We call this type of the distribution as a marginal distribution. Any joint probability distribution can construct one marginal distribution as well. So if I just choose that one for the x as well, if I put instead of the y the x values over there, then I have the distribution separately for the x values as well. So let me just erase the part for the y, and instead of g I will use the h function, and this y also should be changed. So we have the following things, means that at the first line, instead of that one, if I put x equal to xi, and if I name this function by h of x at the point xi, means that without considering the value of y, I want to know that what is the probability for x, means that 129, 130 and 131 are the selected value for the x. So we have 3 values over there, and for each of them I can add them to find the marginal values, means that I will put a summation notation over here and I can add them together. So it will be 0.2 for the first one. For the second one, if I add them, it will be 0.7, and as we expected, the last one should be 0.1. So this is the distribution for the whole cases that we have it, and the addition of all is equal to 1, of course. So means that we have 0.2, 0.2, 0.7 and 0.1, and as you can see over here, these are the distribution function because the addition of these values are equal to 1 and all of them are positive. So we have 2 marginal distribution over here that we can create it based on a table for a joint probability distribution function. So let us take a look at the another example that we have it here. We return back to the previous example on a discrete case. Let us consider that we have 2 chemists and 3 mathematicians, and we want to make a committee of a size 2. And as you know, when we talk about the committee, the group of people means that their place are not important and we don't have any replacement. The repetition is not allowed indeed. So we want to know that what is the probability distribution function. For example, if over here x denotes the if x denotes the number of mathematician, and y if denotes the number of chemists in this committee. So I just misspelled it, mathematicians and committees. So if x denotes the number of mathematicians and y denotes the number of chemists in this committee, the committee of size 2, then first of all we construct one table like this for x values and y values. Y value will be written in a column and x values in a row. You can change their places as well. It's up to you. I mean, it's on your hand. So we can have no indeed mathematician inside of that committee. It can be possible. It can be possible to have one mathematician, or it can be possible to have both of them as a mathematician. So we have 0, 1 and 2 as a possible value for x. If the number of the mathematician was only 1, then we had only 0 and 1 as a possible values. For the y values as well, we have 0 cases, or 1 cases, or 2 cases, because we have 2 chemists in our team that we can collect the committee of size 2 from that one. So all these possible cases can be considered over here. Let us calculate the first value that we have it over here to know how can we calculate it. I mean, for a point 0 and 0. For this point I want to calculate it. So the possible cases for that one means that it's as the same as calculating the probability of number of mathematician x is equal to 0, and number of chemist over there also is equal to 0. But it's impossible because the committee is of a size 2. So this value, the probability of x equal to 0 and y equal to 0, that we denoted by f at the point 0 and 0, is equal to 0, because it's impossible to have no mathematician or no chemist on that group. So this probability is equal to 0. With the same logic, the next point is 0 as well. The probability of the next one is 0 as well, because it's impossible to have only one mathematician on that group. But the next one is possible. Let us calculate the next one. Means that I want to calculate the f at the point x equal to 2 and y equal to 0. Means that I'm looking for the probability of x equal to 2 probability of x equal to 2 and y is equal to 0, means that I need a committee of a size 2 that both of them are mathematician and there is no chemist inside of that committee. So to calculate that one, first of all, I select 2 persons out of the number of the people that we have it in our team. Means that totally we have 5 persons, so it's 2 out of 5. At the numerator, I want to choose 2 mathematicians, means that 2 should be selected out of 3, and I want to have 0 out of 2 persons from the chemist part. So what is that value? It will be 3 at the numerator. At the denominator we have 10, so it will be 3 over 10 or 0.3. So the value over here will be 0.3. Again, it's impossible to have only one chemist and no mathematician, but the only possible way is having one mathematician and one chemist. So let us calculate f at that point. Means that f of 1 and 1 can be calculated. 1 and 1 means that the probability of x equal to 1 and y equal to 1, and that means that we need a committee of size 2 that contains one mathematician and one chemist. The denominator of that probability is as the same as the previous denominator because we select the same person, but at the numerator we need to select 1 out of 3 because we need one mathematician, and 1 out of 2 because we need one chemist, and 2 times 3 is equal to 6, so the result is 0.6, and I can replace 0.6 over there as well, 0.6. And again, for the next case, it's impossible to have any possibility like this, so this value is equal to 0. For the next case, it means that when we have f of 0 and 2, care about it. As you can see, f of 2 and 0 and f of 0 and 2 are different. So you should care about the location of the points that you use it over there. It's an ordered pair and their places are important. I mean, when we put them as an ordered pair. So y equal to 2 means that I need a committee that contains 0 mathematician, so because of that I should choose 0 out of 3, but I want to choose 2 chemists out of them, means that 2 out of 2 should be collected over there. The denominator is as the same, it should be 10, so the result will be 1 over 10 or 0.1. Then I will put 0.1 over here. As you can see, it's impossible to have 2 chemists and 1 mathematician, and of course it's impossible to have 2 mathematicians and 2 chemists simultaneously because we have a committee of size 2. Right now I sketched that distribution function over here. This is the joint probability distribution for x and y, means that x and y value over here at the point x and y is given by that table. We construct the joint probability distribution function. Right now, if I want to sketch the marginal distribution, we need to put 2 lines over here and put their addition there, means that we can calculate their addition right now. So if I determine the x joint probability distribution function by g of x, then g of x is as follows. I can put 0.1, 0.6 as the addition of the value in a column. So as you can see, I add all of the values in a column to calculate it, and 0.3. For the rows as well, we can do the same, means that we have the first row here 0.3 and the second row 0.6 and next one is 0.1. So, and these values determine the marginal distribution for y, and we denote it by h of y. Right now I have 2 distributions which totally determined by the y values and x values respectively. So over here, for example, I can make them in a one separated table. Let us sketch that table as well. So as you can see, these are the marginal distribution functions related to that joint probability distribution function, and moreover I can sketch them in a 3-dimensional space. So we have the point 0, 0 at the origin. Let me just denote it here. This is the origin and it's a 0, 0. Then if this line, this axis determine x and this axis determine y, then we have 1 and 0 here, 2, 0 and 1 here, 0 and 2 over here. So this point, for instance, here is 0, the x value is 0 and the y value is 2, and for each of them, that's 9 values over there, we have the similar actually values, corresponding similar values. At the point 0.3, the probability at the point 0 and 2 is 0.3. Let us sketch that one, and it's as the same as 0.3. So at the middle, when we have 1 and 1, the value is 0.6, so it should be 2 times bigger than the previous one. And at the point actually 2 and 0 means that over here the value of the probability is 0.1, so it's smaller than that one. So this is the shape of a function of a joint probability distribution functions. So moreover, we can talk about the probability of some region. For example, for instance, in this case I can talk about the probability of for example x plus y is greater than 1. What is the probability of x plus y is greater than 1? So to calculate the probability of this one, we have two methods to calculate it. One method is determining the region at the bottom and then add all possible cases over there. The another one is finding the points one by one. So if I just take a look at the point x plus y greater than 1, first of all I should determine the region of x plus y is equal to 1. So to know what is that region at the ground, I should determine this region over here. So if I want to determine it over here on z equal to 0, then I should give the points to that actually line. It's a line, so I just give 2 points. I will sketch the t table and put two values. For example, if x equal to 0, then y is equal to 1. If x equal to 1, then y is equal to 0. So the point 1 and 0 is here, 0 and 1 is there. So the line that we have it connected between these two actually values, so it can be sketched like this. I mean, it's a line of x plus y. X plus y is equal to if I just sketch it, is x plus y equal to 1. X plus y, let me just write x plus y is equal to 1 is this purple line. And if I just examine 1 point, for example 0 over here, we have the origin here that is equal to x equal to y equal to 0. And if I just add x and y equal to 0, then 0 plus 0, 0 plus 0 is equal to 0, and of course it's smaller than 1. So it's not greater than 1. So the another side of that one will be a region that we want it. I mean, this is the region. So as you can see over here, all points of the function will be included in these values. I mean, if you consider this region over here, it's extended up to infinity indeed. Then all of these three lines, three straight lines that I have it as a value of a function will be included on that region. So this probability should be equal to the summation of all cases, which is 1. However, we could calculate the value of that probability by calculating the specific value which is inside of there. Means that of course it's as the same as a probability of 1x equal to 1 and y equal to 0, y equal to 0, and also all another cases. If I add all of them together, the result will be as the same. I mean, the result will be 1. If you choose all possible cases over there, the result will be 1. So at the end of the day, let us have a quick review about the double integral, and let us prepare ourselves to enter to the continuous joint probability distribution. So for sure this is a quick review about the double integral. However, if you want to get expert in that one, you need to review the calculus 1. So if we have a surface like the things that we talk about it, and let us denote that surface by z equal to f of x and y, and if a domain is given to us, means that there is a domain that we denoted by that yellow part over here, and we want to calculate the volume under the surface that is restricted to this domain. Let me just write the domain by D. So means that we want to calculate this actually volume, means that we have one volume over here that can be constructed by that domain, and at the end of the day we have this type of the shape, and we want to calculate what is the volume of that one over here. So we can have this part to have a better illustration about the domain that we want to calculate the volume respected to that one corresponding volume. So over here, to calculate that one, first of all, we need to somehow calculate the volume by using some cubical rectangle. What do I mean by that one? I choose the delta x over here. Let us consider that part is a delta x, and also I select one small segment that we denoted by delta y over here. Let me just put delta y over here, and by using this delta x and delta y, I try to calculate the volume of the shape. This is the things that we severally do it in the engineering, means that we just use this technique to calculate the flux of a water, to calculate a lot of things. So this is delta y and this is delta x. If you can see over here, we just use delta x and delta y, and we construct one actually square over here that is located over here, means that if I just color it by the purple, you can see that it's the delta x and delta y at the bottom of the shape. So with that delta x and delta y, I need also one point inside of that region. So let us choose one point over here that is located by the points xi. Let me just put xi over here, and yj for the another coordinate of that point. Then the height of that point determine the height of that actually cube, means that the height over here is a z I and j. Let me just put it z I and j, that is equal to f of xi and yj, f of xi and yj. And with that height of the cube that we have it over here, we can construct the cube as well, means that we can put that line over here. So let me just shift the line at the location. So this is the line with the same height. We can have the another points and the another points as well. We need four actually line to construct that cubical shape, and at the end of the day, by connecting them, I can have this actually shape. So I denote the volume of that cube by vi and j. So the Vij denotes the volume of the given cube. So if you take a look on it, one side of that one, if I have one cube over here, let me just put a cube over here to show you what do I mean by that things. So if you have a cube over here, and this cube is determined by this size over here. One side is given by delta x, the another one is delta y, the another one is given by delta y, and the length of that one will be equal to f of xi and yj, means that this side has the length of f of xi and yj. So right now, to calculate the volume based on a high school definition for the volume, you can calculate that one as a f of xi and yj as a one side of that one, and multiply that value by delta x and delta y. So I multiply this one by delta x and delta y. But the total volume is the addition of these values. So if I want to calculate the total volume, means that V, then I should take the double summation of these things, these volumes, means that this is the double summation of I and j, vi and j, because one times I should take the sum on a I values in a x line and one times on a y line. So means that it's as the same as calculating the double summation of Vij, and I can put the value of them over here, means that j, let me just put I here, and the corresponding value for them is this volume. So if I have this double summation, can be symbolized by double integral. So means that instead of that double summation, I should write the double integral over the given region D, the domain that we have it D, of the same function, and instead of delta x and delta y and xi and xj, I can write the f of x and y, and instead of that delta x and delta y, I will write their differential forms, means that dx dy. This is the meaning of the double integral, and how can we use the double integral to calculate the volume. But the important part of calculating the double integral is finding the boundary of the integral, the limit of the integrals, the things that we should write it over here to calculate the given integral. Let us focus on that things as well. If the situation is like this, I mean we have a surface of z equal to fxy, and we want to calculate the volume under the curve when it's restricted at the given domain, and the domain is a triangular shape like this. I mean we have the domain D. Let me just change the color to see it better. So the domain is D, and I want to calculate the double integral of fxy on D. It's important to know what is the region, and based on a given region, how I can determine the domain of that double integral. So I want to calculate these things indeed. This is the volume that we talk about it, and I use dA as a dx dy. I mean instead of dx dy, I just use dA. So to determine that one, it's better to sketch that domain in two-dimensional space to see that what do we have over there. So I sketched the domain over here, and you can see that what is the shape of a domain, and we need to know what is the formula for this line as well. To calculate the formula of a line, you know that what is the formula of a line. The line formula is given by y equal to ax plus b, and since the y-intercept and the x-intercept of them is given and both of them are 1, means that if x equal to 0, y equal to 1, and if x equal to 1, y equal to 0, then the formula for that line over here is x plus y equal to 1. So it's very important to determine the location of all borders and all points clearly. Means that, for instance, over here, that vertices, that side is 0 and 0. So this is the origin. The another vertices of that one is 1 and 0, which is located over here at the another side edge of the triangle. This is the another edge of the triangle, and this edge of the triangle is 0 and 1. So I determine first the edges of that triangle. The another one is the line or the sides of the triangle. One side is x plus y equal to 1, that I just wrote it over here. The another one is y equal to 0, this side, and the another one is x equal to 0. So it's very important to determine clearly all the sides and edges of this triangle or any shape that is given to you to calculate the integral. Right now I can write the integral in two forms, means that I can write the double integral with the form of double integral of a function fxy with the form of dx dy, or I can write it by the form of dy dx. So means that I can rewrite that one. Let me just use that actually notation for the next part. So I can use it for dx dy or dy dx, as I said it, dx dy or dy dx, and each of them has some differences. They are not the same. It's not simply changing the limit of the integral or boundary of the integral. The boundary is totally different. So first of all, let us take a look at the case that we have dx dy. When we have dx dy and x is written as a first thing, then I should sketch the horizontal line over there. If it's started by dx dy, as I said, I emphasize about it, you should write some horizontal line. Assume that you just look at this domain. This is a domain that we talk about it. Let me just change the color of a domain. The color of a domain is changed, and right now you can see this is the domain. Just consider that domain as a one farmland or some place or some region that you just take a look on it from a top, like that you just take a look on that region by a drone or some airplane. So if you just take a look on it, and these green colors, that arrows determine the soldiers or the farmer who want to enter to this region, it's important to see that what is their entry, what is the region that they enter, that type of the farmer or that type of the soldiers or any things that you want to call them, these people that we have it. If they just travel horizontally to that region, they enter to that region from this border, and this border is x equal to 0. So I will write the border over here, means that x is equal to 0 is a border that they enter it, and they get out from that farmland from this border, and this border is x plus y equal to 1. And if I want to write it in terms of x, means that x is equal to, if I just write it over here, x will be equal to 1 minus y. Always you should do the same thing, means that it will be 1 minus y, the border that the soldiers or that people just get out from their given region. For the second boundaries, you simply write the value for the y. From the beginning, the value is started from 0 and it's going up to the point 1, so the boundary will be 0 up to 1. We should do the same thing when we have dy dx, but this time you should sketch the vertical line or vertical arrows. Okay, so if you just sketch the vertical arrows, then based on that vertical arrows, as you can see, the border that the soldiers just get inside of that land is y equal to 0. As you can see, if you just sketch it, it's y equal to 0. And the border that the soldiers or that farmer just get out from the region, it's this border, because when they just arrived and want to get out from the region, they should pass this border, they should get out from this border, and this border in terms of y is written like this: y is equal to 1 minus x. So you should write it by 1 minus x. 1 minus x should be written over here, and at the end of the day there is the value for the x that should be considered over here, and the value of the x is started from x equal to 0 up to x equal to 1. So the boundary will be 0 and 1. So this is the concept of the double integral, the quick review about that things. However, you need more ability to calculate the double integral for the polar coordinate or a spherical coordinate, and we will discuss about that type of the cases in the next lecture. And in the next lecture, with the details, we will study some specific cases, and you will see how can we deal with that one. I hope that you understand the concept, and thank you for your attention in this lecture. Thank you.